50 pound is the max. So we have a range of 5 to 50 psi pressure drop capability across the valve. Now, does that mean the valve's not going to work if it's greater than 50 or less than 5? The valve will still work, it just won't work as a pressure-independent valve. What that means is if you're below 5 pounds, which is really all I've ever seen it be above 50 pounds. If it's below 5 pounds, then pressure changes will have an effect. As long as you're in that 5 to 50 psi drop across the valve, you won't see any changes in the flow through the valve based on just pressure changes. You're only going to see changes if the building automation system calls for a change in opening. Various parts of the PICCV, well, we have the characterizing disc. Like I said, this is part CCV. We look at the upstream pressure here. Got your diaphragm down here with your spring, then the downstream pressure. Then once you compare those two through the pressure transfer channel here and pressure sensing ports, that's what adjusts that pressure regulating device. Now, around the opening at the end of the valve are the pressure sensing ports. One thing that those of us that were with Belimo at the time this was introduced, we were concerned about was, well, those look like some pretty small holes around there. Couldn't those get clogged? They don't. The reason being is you've got flow flowing by there, and so it's a Venturi effect. You know, if the flow were to stop, yeah, maybe something could stop over one of those holes. As soon as water starts flowing again, it pulls everything with it. So there's no problem there. So, as far as selection and installation, not necessary and not recommended to install any kind of balancing or flow limiting devices. A couple reasons for that. Well, first of all, of course, this valve does that for you. Second thing is, in order to maintain your efficiency, or peak efficiency anyway, if you put in a balancing valve or flow limiting valve, that's just adding, or I should say taking away from the pressure drop that could be going to the pressure independent valve. And you want to make sure you have enough drop across that valve. You don't want to have to increase your pumps to get more of a drop because you have those additional valves in place. As I mentioned earlier, PICCV is not rated for steam applications, and you need to be in the 5 to 50 psi drop across the valve. Was lunch here? Or?
Not yet.
Okay.
Just the plates.
Oh, okay. Electronic pressure independent valve. We're achieving the same results in a little different manner here. It's available in two-way configuration, just like PICCV. Like I said, all PI valves are going to be two-way. This 2.5 through 6 inch flow rating from 127 to 713 GPM. So that 127, that's the max for say a 2.5 inch valve. Now, we will set the valves for certain GPM. The lowest will set the maximum range on that 2.5 inches, 90 GPM. Designed for use in waterside heating and cooling systems, and again designed to compensate for the pressure variations, give you the consistent flow that you're looking for. Selection installation information. Input length. This is one thing that's a little different than what we say, but it's really part of best piping practices for all valves. EPIV requires a section of straight pipe on the valve inlet, 5 pipe diameters. We don't require anything on the outlet side. Simplified valve sizing, as I said on the PICCV, you're sizing up these valves based on your GPM as well. Good for hot or chilled water, 50% glycol, mix, mats. Again, it can be installed vertically or horizontally, and we don't want an actuator below the valve body. Like I said, one thing I just wanted to point out, a feature of this that a lot of people really like is that with this magnetic flow sensor, your feedback that you get will give you the flow through the valve. So magnetic flow sensor is tied into your actuator. Your actuator has a feedback wire. Well, the feedback that you get is a linear feedback. So say you've got your 2 to 10 volt feedback coming out. If you had, so 6 volts is 50% of that. If you're getting a 6 volt signal, say it's the 127 GPM 2.5 inch. If you're getting a 6 volt signal back on your feedback, you're going to be getting 50% of that, so what, 63.5 GPM will be going through that valve if you're getting a 6 volt signal on the feedback. So it alleviates the need to have any other kind of flow sensors on there if you're using this valve. The energy valve, as you can see, looks a lot like the EPIV. That's because it's based on the EPIV. We just put a couple additional features in there. It has same flow ranges, everything. Energy valve, same type of application. Hot and chilled water application. Can be used for air handling units, heat pumps, whatever the case may be. Available, again, only in 2-way configurations, 125 ANSI 125 flanges. It's also got the 5-year warranty. Here's the description of what an energy valve is. It's a pressure-independent control valve that optimizes, documents, and improves water coil performance by correcting low delta T. So here we have the valve. Right on this side, that's basically just one of our flanged CCVs. Typical MFT actuator. Bless you. Flow sensor, as we saw on the EPIV just a minute ago. Now the additions to this product, we have 2 temperature sensors, one embedded in the valve itself, the second to be mounted on the opposite side of the coil from the valve. By doing that, we're able to read the delta T across the valve. And then the last thing that was added was a BACnet application-specific controller. With that controller, that stores 13 months worth of data, flow, power usage, things like that. We'll see a list in a minute or two. So, trend and store flow, your delta T, your energy output, power output, and totalized energy. Now, with this product, I see this product as being specific to certain applications, certain jobs, from the standpoint that if you don't have somebody that's going to be looking at the reports that can come out of this valve, at least a couple times a year, you're probably wasting your money because you're paying for something that you're not using. That you'd be better off going with the EPIV at that point, because electronic pressure independent, or actually pressure independent valves in general, are good for all applications. There's no need to go view any kind of reports or anything. But if you have, like a lot of times, university campuses, hospitals, things like that, these are great because those places usually have an energy manager, that type of thing, that's very interested in trying to save energy and more than happy to look at reports a few times a year to see how they're doing. It can also help you with some predictive maintenance.